Good morning to all of you. This is Preeti Verma, Assistant Professor at the College of Pharmacy, Greater Noida. So today I'm here for presenting the topic that is the acid-base titration. So let us start. Before starting of acid-base titration, here I'm going to present first that is a titration. You should know about the titration, why we are doing the titration, what is the purpose behind the titration. You should know all these points before doing the titration. So titration, what is titration? Titration is the analytical technique, and you can also think like that is a branch of analytical chemistry in which determination of the concentration of the unknown sample means you have to determine the concentration of the unknown sample with the help of the known sample, as you can determine the precise endpoint of the sample. So this is all about the titration. When you are doing the titration, you should know these 3 points. First, what is burette, then second, what is indicator, and the third one is that what is endpoint. So burette, as we all know that burette is the most accurate and most calibrated apparatus in your laboratory. So it is basically used for the titration only. Burette, it delivers the secondary reactant means if you determine the concentration of any sample, any analyte, so you should take in a conical flask only, and the reactant you should take only the burette. And the second one is the indicator. It indicates the color change of the reaction, and the end point, it indicates the color change at the end point of the reaction. When you achieve the end point, means you have done your titration. So this is all about these 3 points. And now conical flask and burette, as earlier discussed, conical flask and burette. The secondary reactant will take in burette and conical flask when you have to determine the concentration of any sample, any unknown sample, you have to take in a conical flask. So now when you are doing a titration, which point you have to keep in your mind first when you are doing titration, then first you should wash the burette properly with water, and then rinse the properly burette with a distilled water, and after rinsing the burette with the distilled water, you should check air bubbles and leaks before proceeding the titration. And now be sure the tip of the burette is properly filled. If tip is not properly filled, then definitely you will get the wrong endpoint, means inaccurate rating. So you should check these points before doing the when you are doing the titration. So now at the last, never dispense the liquid is below the last calibration that you can reach. Means you have never dispensed the sample when you have done the last calibration. Now, this is the burette. It indicates the when 2 points you have to keep remember. First, lower meniscus, and the second one is the upper meniscus. When you have to take color sample, then you have to take only the upper meniscus volume, and when you have a transparent solution water like sodium hydroxide solution, then you have to keep the upper meniscus only, sorry, lower meniscus. So this is the burette that indicate the volume of the exact titration. You should keep 2 points in your mind. First, lower meniscus, and the second is the upper meniscus. When you have a color sample, you should always take the upper meniscus. When you have a transparent solution like water, sodium hydroxide, so you should take only the lower meniscus. Next, take an initial volume reading and record it. And the second, before beginning a titration, you should always calculate the expected endpoint volume. Next, preparation the solution to be analyzed by placing in a Almer or conical flask. If your sample is a solid, make it completely dissolved. Means your sample is properly dissolved. If your sample is not dissolved, definitely you will get a wrong endpoint. Then add the indicator. It is a basic role play in a titration. So now use the burette to deliver the stream of the titrant within a couple of ml of your expected endpoint. You will see the indicator change color when the titration hits the solution in the flask, but the color change disappear upon state. Means when you add the indicator, when you add the reactant to the analyte, then color will be changed. When the color will be changed, it not indicate the endpoint of the titration because color will be disappear within a 2 to 3 seconds. When color will be appear at the last, means it will be indicate the end point of the titration. Means color persist approx 10 to 15 minutes, then it will indicate the end point of your titration. So approach the endpoint more slowly and watch the color of your flask carefully. Means your titration, when you are doing the titration, your color look like this. Next, use a wash water to rinse the sided of the flask and tip of the burette to be sure all titrant is mixed in the flask because some of the analyte, some of the molecules stick at the wall of the flask. So you have to rinse all the sample. Make sure you know what the endpoint look like. And that last for phenolphthalein indicator, the endpoint is the first permanent pink color for the phenolphthalein indicator only. The pale pink color faded in 10 to 20 minutes. Now, when you have done your titration, your sample look like this. If you think you might have reached the endpoint, you can record the volume reading and add another partial drop. Sometimes it is a disappear till when you have gone past the endpoint. And next, if the flowers look like this, you have done your titration. Means you are reached to end point of your titration. So end point of an indicator should not be confused with the equivalent point of the titration because equivalent point and the end point both are the different. Like indicator change color at the end point. Next, equivalent point is the stoichiometric point where neutralization take place. Means equivalent point means neutralization take place at the point of the equivalent. Ideally, the end point of the indicator and the stoichiometric equivalent point should coincide. And these are the some common indicators that is used in your titration, like methyl violet, the pH range like 0 to 1, it's showing yellow, and then when pH is 2 to 4 middle, then it's showing uh, violet color. Thymol blue, same acidic color is red and the basic color is blue. Methyl orange next is a methyl red, bromothiamyl blue, and phenolphthalein is a common indicator for the acid-base titration. Then alizarin yellow are these all the indicators that are used in titration. And these all the color change in acid as well as the base. So these all the acid base indicators because in acid they have a different color, in base they have a different color. So these are the acid base indicator. Now these are the titration curve for the strong acid versus strong base. And because a strong acid, as we all know that HCl in a strong base is an NOH. So when a reaction of a strong acid versus a strong base, then what will form? Then salt, that is a sodium chloride, and with removal of water. At the equivalent point means pH 7, that means it showing the equivalent point in a acidic into the base, but base into the acid same equivalent point achieved in the pH 7. So this is all about the titration curve for the strong acid versus strong base. Now the second one is the titration curve for the strong acid versus weak base. So as we all know that a strong acid, that is HCl that earlier discussed, and the weak base, that is the NH3 means ammonia. When these two analyte and titrate react, then what will form? Ammonium chloride, that is the salt. Means that at the equivalent point approx pH is 5, When volume of acidic is added, then again the volume as alkali is added, then also pH is 5. So this is the titration curve for a strong acid versus a strong base. Now the third is the weak acid versus a strong base. So weak acid like acetic acid and a strong base like sodium hydroxide. When these strong base and weak acid react with each other, then what will form? Then CH3CON means acetate, sodium acetate is formed with removal of water. So what the graph showing means approx 9, pH 9 indicate the equivalent point of the titration in the acidic medium, and again volume of acid is added, then pH 7 indicate the equivalent point of the titration. So this is all about the weak acid and versus strong base titration. Now acid, basic and neutral salt. What is the acid, base and neutral salt? A salt is a form between the reaction of an acid and a base. Second, usually a neutral salt is a form when a strong acid and a strong base is neutralized in the reaction. Like H is react with OH, obviously what will form? Water is formed. Then, when weak acid and weak bases react, the relative strength of the conjugated acid-base pair in the salt determine the pH of the solution. Next, the salt or its solution should form can be acidic as well neutral or basic in because these three probabilities here acidic, basic or neutral. So this is the acidic, basic or neutral salt. Next, when a salt form between a strong acid and a weak base is an acid salt. That is example is ammonium chloride. A salt form between a weak acid and strong base is a basic salt. For example, like sodium acetate. And the third one, these salt are acidic, basic due to their acidic or basic ions as shown in the tables, like this. Ions of neutral salt like pH is equal to 7, cation like sodium, potassium, magnesium, calcium, etc. And anion like chlorine, bromine, iodine. So these are the anions and cations. Basically, the pH is 7. And now acidic salt like pH is less than 7. So acidic ion like ammonia, aluminum, and HSO4 minus. Transition state metal ion like Fe2 plus, copper 2 plus, lead 2 plus, tin 2 plus. So this is the acidic salt which have a lower pH. Now basic salt like pH is a more than 7. Acidic salt pH is a less than 7 and basic salt is pH more than 7. So basic ions like fluorine, cyanide, these are the basic ion that is used in your titration purpose. Now these are the references that will be covered in all the my presentation. Thank you so much for watching this video. Thank you.